Okay, so here we are going to start looking at our trig formulae, and in particular we're going to look at the area of a triangle. So firstly, before we going to launch in and do that, we need to think about how it is that we're going to name a triangle. And so rather than simply using our kind of describing words to tell us what type of triangle it might be, whether it's equilateral or right angle, scaling, etc., we need to have a way of referencing particular parts of the triangle. So every vertex in a triangle gets named with a capital letter. Now sometimes the question will have done it for you, sometimes you get to do it. But take a triangle, any kind of triangle, and each vertex, or the pointy bit, the cornery bit, gets labelled with a capital letter. So we creatively are just going to go A, B, and C. Okay? Once we have done that, each side opposite gets labelled with the same letter but lowercase. Okay, so all the opposite sides from the angle are then labelled the same, lowercase. So A, the side opposite is that one, so it gets a little a. From the vertex at B, the side opposite's over there, so it gets called a little b. And then at vertex C, right across, it gets labelled little c. And this is what all of our formulae are going to reference. They are going to assume this naming convention. Okay, we are given the formulas in the formula sheet as it is just now, and they will reference it assuming A, B, and C. Okay, we'll look at how we change it, etc. if we need to, but that is what they are going to reference, and this is going to be true for any kind of triangle, whatever type it is, be it, like we said, right angle, equilateral, scaling, blah blah blah. So if we have a triangle and we just keep the names, keep the labels in the same place they are, ABC, ABC, how can we find the area of it? Well, the formula we can use is actually a half AB sine C. Okay, so the area that we're used to finding is half base times height, whereas this one here, what we can do is we can take any two sides and the angle between them, and we can use that information to find the area. You do not, he stresses, do not have to show us where these formulas come from. You are simply expected to use them just now. And as we take it forward, progressive years, then your geometry skills will advance and you can show me when then. Right? But just now, all you've got to do is be able to use the formula. So what we want then is we want little a, little b, and that's a capital C in the sign there. So I need an angle and the two sides between it. Okay, so that is then what it is that we are referencing here in particular. So a little a is length A, little b is length B, and big C is angle C. So we want to find the area of, let's take this triangle here. I've got an angle and I've got two sides, either side of it. So I'm going to use my formula. So the area is equal to half AB sine C. So because I know my angle is at 30 degrees, that's where the C side has to be, because it's the angle that I'm interested in. For my formula, I know the angly bit happens at C. So that makes the other side opposite at C, which makes the other two vertexes A and B, and labeling across from them I get little a and little b. Okay, in theory, whichever way round you do your A and B there don't matter. Okay, you could label vertex B at the top and A at the bottom if you wanted. So anyway, next, all I'm going to do is substitute my numbers in. So I've got a half times 10, that's the number on my little a side, multiplied by 16, the number on my b side, multiplied by the sine at C, which is 30. Crunch my numbers, ask my calculator, and it will give me 40 as the answer. So the area of that triangle is 40 square centimeters. Okay, next one. I've got a triangle here, a kind of pinky triangle. And this time I'm using different layers. Okay, this time I've got L, M, and N. And the information we've got is that we've got an angle of 60 degrees at N, and then the sides either side, a 12 and a 15 centimeters. So I want to find the sides first. So we're just going to label our triangle. And so before we launch into what it is we're going to do, it's always a good idea to label our triangle first. Okay, if nothing else, it's going to help us work out which of the formulae it is we need to use. We can look at the bits that we've got and we can try and match it up. So, I know I want to find the area, so my area formula is a half AB sine C. Problem I've got this time is that I've used different letters. I don't have those letters in the triangle. And so I need to adjust my formula to match. And so the angle is where the sine bit is. So the angle should say C, I've actually got N. So my area so far is going to be a half times something with the sine of N. Okay. I know that the two sides I've got are L and M, and so I'm going to write them in place instead. So rather than AB, I've got LM. And what we need to do is make sure the formula matches up to the one above it. Okay, I've got an angle at the two sides either side of it, or two sides and an angle between them. Okay, I'm not just picking two random sides because they're the two that I've got information about. Okay, it has to be two sides and the angle in between it. So when we're looking at this area formula, each letter should only appear once. I've got an L, an M, and an N. One capital, two lower cases. If we start seeing a letter in there more than once, we've done it wrong. Okay. After that, all we need to do, substitute in our numbers. So we've got a half times, what number is there on the L side? I've got 12. What number is there on the M side? I've got 15. What angle is there at N? I've got 60. Turn to our calculator, crunch our numbers, and we get 77.9 square centimeters.